Hey everybody, this is Trey with BlackFalconElectronics.com, and in this video I will be discussing Project RCAT, or the Remote Canine Automated Tracker. If you would like to see more updates to this project, you can like, share, subscribe, share with your friends to spread the word, and you can also find me on Instagram, Patreon, Facebook, all under Black Falcon Electronics. So let's go ahead and get into the video. So the point of Project RCAT is when I go hiking, go out and about in the woods or the forest, national parks, things like that, I'm going to have my dog Atlas, which you guys have seen before. He's going to be coming with me. Big thing with me is when there aren't a lot of people around, I like to let him off leash, and I want to have some kind of safety system so that if I do let him off leash and for whatever reason he runs away, I have a means of identifying where he is so that I can go get him. I don't want him on the leash the entire time because it's good for them to be able to go run around, sniff around, what have you. And while he can easily be recalled, still, you never know, because you never want to just always have them on a leash. So what I want to do is make a system that can not only receive GPS coordinates, but save those coordinates and somehow send it to me so that I can receive it, and then from there I'll know where he is in relation to me so that I can go find him. So that's where we have this plan right here. So I'm going to put it in focus and explain it further. So here we have a couple of items. Here is the controller. This is in the center. This central unit is basically the central processing unit, if you want to think of it like that. It's a microcontroller that determines the input and output of the different sensors that it will be attached to. So the controller will have a light, SD card, radio, GPS, and a compass. So obviously the GPS is going to use the US's global positioning systems. That'll give me the latitude and the longitude. The compass is going to tell me his relative direction as well as my relative direction. So am I more north, east, south, or west? The light is so that if it's dark outside and I want to easily find him, as well as using the GPS coordinates, I can also have a light activate so that it starts flashing, strobing, so that I can easily find him without having to, go through the dark, because with him having black fur and it being nighttime, if I decide to go out during that time, it'd be very hard to find him. And your SD card saves all that data and can broadcast it out as necessary if I choose the right settings. And then you obviously have your radio, which sends and receives information. So the big thing out of all of this is mainly the GPS, because without the GPS, nothing really works. I could send whatever data I want, but nothing will work. But let's first explain how GPS works. All right, so you have your latitude and your longitude. Easy way to remember is, if you guys remember being in high school, your latitude references your x-axis, which is horizontal. So this would be your x-axis, and then your y-axis will be your vertical. So anytime you're giving coordinates, you're going to do x-axis first, which is latitude, and then your y-axis, which is your longitude here, okay? So your latitude goes from north to south. So I'll go ahead and write it here, north to south. So it goes from the minimum being negative 90 degrees to the highest being positive 90 degrees. And in the middle, you have the equator. The equator is 0 degrees. And the more north you go, the higher the positive number. So if you go more north than the equator, it'd be positive 10, 20, 30, 40, 50, 60, 70, 80, 90 degrees, which is your maximum for your north. And then for your south, once you go below the equator, it'll be negative 10, 20, 30, 40, 50, 60, 70, 80, 90 degrees until you hit the South Pole, and that'll be that. Now, you'll see in a lot of these degrees, when you give your lats and longs, you'll see degrees north or degrees south. Now, for your latitude. Now, you don't necessarily need to denote if your latitude is degrees north or south, because if it is a positive number, your latitude, if your latitude is a positive number, then it's automatically degrees north. And if it's a negative latitude, then you already know it's degrees south. But it's just an easy way to quickly identify, is it positive or negative? Is it north or is it south? Okay. So Next is your longitude, or your y-axis, your vertical. So for your longitude, it does not go 0 to 90. It goes from 0 degrees to 180 degrees. Now, the 0 degree longitude, that will be going through Greenwich, England. And the more west you go more negative until it goes negative to negative 179.99999. And then once you get to 180, that automatically goes to a positive. But the more eastward you go, then it goes positive 10, 20, 30, 40, 50, so on and so forth until you get to 180. Okay? Now, when you see your longitude, it goes from east to west. Okay? So when you see your longitude values, you will typically see it in degrees east or degrees west. But again, if you know that your longitude, which is your vertical or y-axis, if you see that its number is negative, you should already know it's in the Western Hemisphere. And if you see that the longitude value is positive, then you know it has to be in the Eastern Hemisphere. But again, like I said, for the latitude, for when you have your longitude, it's good to have your east-west because you can quickly identify the information instead of having to stop and think about it. Because not a lot of people really intuitively know, oh, if it's positive or negative latitude, that's degrees north or south. If it's positive or negative longitude, then it's degrees east or west. You know what I mean? So by using these set values, your latitude, longitude, you can easily identify with the ARCAT where you are and where the dog is exactly, where my dog is exactly. Okay, so now let's go to the Lat and Long so we can talk a little bit about it some more. All right, so here I have a sample GPS coordinate situated and listed. So here, because the latitude is 52 and that's a positive number, we already know that this degree is in degrees north because it is above the equator, and we know that the longitude is negative. So if it's negative 47, then we know that it's in the Western Hemisphere. So then we can say degrees west. Okay. Now you will normally see this for your Google Maps, right? This is in decimal degrees. So decimal degrees. All right. But what I have found more useful is to convert your decimal degrees to degrees, minutes, and seconds. So what I like to shorten it as, because, I like to abbreviate everything, we can call this your GPS DD, which is decimal degrees. And then you have your GPS DMS values, which is your degrees, minutes, and seconds. Now, this is exactly the same. So how do you convert your GPS DD, or decimal degrees, to GPS DMS, or degrees, minutes, seconds? Well, all you have to do is do some multiplication. So to change from GPS DD to GPS DMS, you have to multiply by 60 because these go by 60 seconds, okay? So if we want to do it, you would see your 52 is always brought down, and your negative 47 is brought down because that's just your degrees, point blank period. Now to get your minutes and seconds, you would do your, right about here, you would do 0.5183 and you would multiply that by 60. And then when you get your result, you would then use your result and multiply that by 60. So you already have your degrees. This will be your minutes. And then here, whatever your result is, this will be your seconds, okay? So let's go ahead and erase this and let's actually do the math. All right, so to do this math, we already have the degrees, which I said before, 52 for the lat, for your longitude is -47. But next, we need to get our minutes. So what we're going to do, make sure you guys can see, we have 0.5183 times 60. There you go. All right, so obviously you're going to have your zeros, 2, 3, 4. Then you're going to do 6 times 3, which is 18. Then you're going to do your 8 times 6 plus 1, which should give you, let's see, 49. 49. Then 6 times 1 plus 4, that'll be 10. And then 6 times 5 plus 1 should give you 31. Okay, so you have, and you need to bring it down right here. This would be 31, bring down a decimal point. So this here is your minutes, which you see here for the latitude will be 31 minutes. Now this leftover, this 0.098, that is what you need to multiply by 60 to then get your seconds. So to do that, we're just going to say 0.098 by 60. Obviously, you get your zeros. And then now you need to say, what is 6 times 8, not 8 times 6, but it doesn't matter either way. So 6 times 8, that'll be 48. 48. Next, you need to do 9 times 6 plus 4, which is 58. 58. And then you have 6 times 0 plus 5, and that'll give you 5. So here will be 0.5, and you can add a 0 right here. So this will be your seconds, and you can check the math if you need to. So your degrees for your latitude is going to be 52. Your minutes is going to be 31, and then your seconds is going to be 5.880, but you can just shorten it to 5.88, okay? And then, of course, you can do the same thing to find your longitude. You would just do the same math. You just do 0.351 times 60, and when you get that result, you multiply that by 60, and then you'll get your result, which is be a total of -47 degrees by 21 minutes by 3.6 seconds. Now, what is the importance of using decimal degrees versus your DMS values? So the importance of using your DMS values instead of your DD values, there's not really much of a difference, but the big thing for me is that since I'm using the compass, if I use the compass and I point myself, let's say to true north or magnetic north, because it's going to be going, the compass goes by magnetic north. If I point myself to magnetic north and I see values of 0, and then I see what my GPS coordinates are, and then I see what his GPS coordinates are, if I see that the difference between my GPS coordinates and his GPS coordinates, Atlas's GPS coordinates, is off by a couple seconds, I know he's pretty close to me. But if it's a couple of minutes, I know he's far away from me. So that lets me know the urgency I need to take to get to where he is. And if he's like degrees away from me, then he is far as hell away from me. So that's why it's better for me to use DMS values as opposed to DD values, because it's easier to determine with what speed I need to go in order to get him, to retrieve him, so what have you. Yeah, to get him or to retrieve him. So if any of you guys are interested in supporting me and supporting BlackFalconElectronics.com, all you got to do is go to BlackFalconElectronics.com/shop, and here you can buy a Sparrow Programming Kit. Now this is a kit that I put together myself. It comes complete with the code as well as tutorial files that actually teaches you how to program all of these items and make projects. So it teaches you the basics of coding and how to put these projects together so that you're doing more than press a button and then something happens, but it teaches you the richness of the why. Now anytime you buy a Sparrow Programming Kit that you see here, you also get free tutorial file that comes in with the kit itself. So here, if you click Sparrow Kit tutorial files, you'll see the download. You click here to access the files, and then here's the password you would have to put in. Now that password you would get when you go ahead and open up your Sparrow Programming Kit. Once it gets shipped to you, it has a password in it, so then you can just come here, put in the password, and then you're good to go. So thank you guys for watching the video. I really appreciate it. Like I said, please like, share, subscribe, share with your friends, and you can find me on Patreon, where you get exclusive detailed videos 2 weeks early, and you also get detailed explanations for some of the programming that I'm using. So you can find me on Patreon, Facebook, YouTube, Instagram, all under Black Falcon Electronics. So have a blessed day, and I'll see you in the next video. Bye.